Okay, back at Biomechanics again. I'm Emma Mott from RCW, and today I'm going to demonstrate acceleration by moonwalking, so it should be a fun time. Keep in mind that I'm not the best moonwalker. I'm no Michael Jackson, but I'll do the best I can. So before I get started, acceleration is defined as the change in velocity of an object. And we kind of went over velocity in the last module, so it's just kind of building on that.
Alright, so since acceleration is the change in velocity over the change in time, it would make sense that we need to find our velocity first, then find our acceleration. So what I did is I took the total displacement divided by the total time to find my velocity, which was 45 feet divided by 22 seconds, because that's how long it took me to moonwalk in the gym. And that would come out to be about roughly 2.045 feet per second. So that would be our velocity. And so now that we've found our velocity, we can now factor that into our acceleration equation. And the formula for acceleration is your final velocity minus your initial velocity divided by your final time subtracted by your initial time, or delta V divided by delta T. And delta basically just means change. And just to point out, both acceleration and velocity deal with direction as well as speed. So as you can see, I'm moving very slowly, I might add, in the left or east direction, which also doesn't necessarily mean I have a negative acceleration. Keep in mind that the SI unit for velocity is meters, so I converted what I originally got for velocity as feet to about 0.028 meters per second. And now I'd just like to talk about some different types of acceleration that we've learned about so far. So there's the instantaneous acceleration, which is basically just acceleration at that instant in time. Uniform acceleration, which is the most common that I found, which is constant and it's unchanging acceleration as well. There's variable acceleration, which is the opposite. It's, non-uniform acceleration. There's also positive acceleration, which is just the velocity of the object increasing. And then there's the opposite of that, and negative acceleration, which is just the velocity of that object decreasing, which doesn't always mean it's traveling in the positive direction or in the negative direction. It depends on the initial velocity and final velocity of that acceleration equation. One thing I didn't demonstrate in this video because I wasn't, falling off a cliff was the acceleration due to gravity, which is equal to negative 9.8 meters per second squared. And that was a wrap of acceleration. Thanks for watching!